Hello, sixth grade. So today I will be introducing section 4-4, equations and inequalities. There are 4 vocab words here, so if you would pause your video, write down your heading, go find the definitions for your vocab words, and then come on back to the video. Alright, our first 2 vocab words really go hand in hand. So we have closed sentence and open sentence. Essentially what this means is you have an equation, which suddenly we have an equal sign. We don't just have expressions anymore. We have an equal sign saying that 2 expressions are equivalent. If you have a closed sentence, that means that you don't have any variables. You only have numbers. So an example of a closed sentence would be this. We have numbers, we have operations, we have an equal sign. Let's say 7 plus 2 equals 9. So we have 2 expressions, 2 numeric expressions in this case, that are equivalent to each other. 7 plus 2 does equal 9. But this is a closed sentence because there's nothing that can change about it. It's kind of like it's a locked equation. There's nothing that can change about it. We just have 7 plus 2 equals 9. If you have an open sentence, though, that means that there's a variable somewhere in your sentence. So say we have 2x equals 17. So 2x equals 17 would be an open sentence because we have an open variable here. We don't know what x equals. It's open. It could be anything because that's what a variable means. It's something that we don't know. So it varies, which means that this is like an open door. This could change depending on what we say x is. A solution is what you would put in for your variable that would make your equation true. So we have to figure out what can we put in for x that would make this true. That would be your solution. Whatever you're going to substitute in for x that would make your equation true. An inequality, I know you guys are familiar with less than, greater than, we've done those, and oops, less than or equal to, greater than or equal to, we talked about earlier this year. When you're talking about an inequality, that is saying that one side or the other, so the expression on this side or the expression on this side is greater than, less than, greater than or equal to, less than or equal to what's on the other side. So that is an inequality. I want you to make sure that you write this chart down that's on page 129. So this would be less than, and remember that you can make that less than sign into an L and write less. This one is greater than. And then of course less than, or, so it's or, not and, less than or equal to, and greater than or equal to. This chart has one other thing. It's an equal sign with a line through it. That means not equal. So you're all super familiar with the equal sign. All you do is put a line through it, slash through it, and that means not equal. So these are symbols that we'll work with when we're talking about inequalities. Translating words into math, if you see less than, you would put the less than symbol. Greater than would be this. Less than or equal to would look like this. Greater than or equal to, not equal would be the equal sign with a slash through it, and equal would just be a regular old equal sign. So the next thing we're going to do is look at our first section here, which has the directions that say write as an equation, then label each equation either open or closed, write whether it is true or false. So you can only do that if it is a closed equation. If it's open, we don't know if it's true or false because we're not told what the variable equals. So we don't know for sure if it's true or false. If it's open, if it's closed, then we can say it's either true or false. Number 1 says a number divided by 3 and 85/100 is equal to 1. So a number means we're going to have a variable. I'm going to use n here. Number divided by 3 and 85/100 is equal to 1. That is what our words are telling us. This is it translated into math. The next thing we're supposed to do is decide whether it's open or closed. Because there's a variable in here, that means it's open. So number 1 is open. We can't then say if it's true or false because we don't know what n is. Number 3 says 2 more than twice a number is 3. So is where we're putting that equal sign, just like you would say 2 plus 3 is 5. Is your equal sign. So here we have 2 more than, so 2 plus, twice a number would be 2n is 3. So again, this is open because we do have a variable here. So this is open. We can't say if it's true or false here. Let me give you an example real quick of a closed statement in case you happen to get those in your evens. So if we said 7 plus 3 minus 2 equals 8. This would be closed because we have no variables here. So we would say closed, and then we would do the math, and 8 does equal 8, so we would say that it's true. So if you have a closed statement with no variables, you're going to solve it out. If it's true at the bottom, so 8 does equal 8, and it would be true. If you came up with something like 10 equals 8, then that would be false. Okay. Moving on to the next section, our directions say, determine if the given value of the variable is the solution of the equation. So remember, a solution of an equation means that you're going to plug that number in for your variable, and it's going to work out to be true at the bottom. If it is true, then whatever number that you plugged in for your variable was a solution. If you come out with something like 10 equals 8, that's false. That means that whatever you plugged in for your variable is not a solution to that particular equation. So number 5 tells us 9x plus 8 equals 35, and it tells us to check for x equals 3. We're going to go ahead and plug in or substitute in 3 for x. Oops. And then we can use our order of operations to solve this. And we do come up with a true solution here. 35 does equal 35. What that means is that 3 is a solution to this equation. So when we plug 3 in, we came out with a true statement at the bottom. That means that 3 is a solution to that equation. The next one we're going to try here is number 7. And they tell us to try it for k equals 12 3/10. So we're going to go ahead and plug that in anywhere there's a k. And we need to divide that out. It should be 4 1/10. When we add these together, we get 9 equals 8 5/10. Well, that's false. That means that 12 3/10 is not, no, it is not a solution to this equation. There's another number that is a solution to this equation, but 12 3/10 is not it. Moving on to the next section, it says write as an inequality. So we're translating from words into math, and we're going to be using our less than, greater than, less than or equal to, greater than or equal to, or maybe not equals. And we are to decide whether or not it's opened or closed. If it is closed, we're deciding if it's true or false. So for number 9, it says one more than, so we're adding 1 to something, twice a number, is 2 times the n, is greater than 3. So 1 more than twice a number is greater than 3. When you translate these into math, if you read it back, that's a great way to check whether or not you wrote the right math. So we did. This matches what our problem said. This particular inequality is open. We have a variable there, so we can't decide if it's true or false. Moving on to number 11, it says 19 is not equal to, so we have our not equal to sign, the sum of 1 and 1/10. So 1 and 1/10, that's the number, the sum of 1 and 1/10, and the sum of 1 and 1/10 of 100. So this is not 1 and 1/10. So you can see it gets a little bit confusing when you have a decimal in there, because you're not sure if the and is what you're adding or part of the decimal. But when I read on, it was 1/10 of 100. So that was a multiplication problem. So here we have the sum of 1 and, so we're adding 1 to something. What we are adding it to is 1/10 of means multiplication. So 1/10 of 100. So that's what's on this side of our equation, which we know it's not equal to. We have no variables here, so we can decide now, is this true or not true? If it's true, that would mean that what's on this side is not 19, because 19 was here and it says 19 is not equal to whatever's on this side. So let's solve this out and see what this does equal. I'm going to do this multiplication first. 1/10 of 100 would be 10. So now we have 1 plus 10 is 11. 19 is not equal to 11. That's true. So this one would have been closed, and it is true because 19 does not equal 11. The last one is number 13. 13 says the quotient of a number divided by 7. So a number, the quotient of a number divided by 7. So that would be, a number is n divided by 7. This is 13. The quotient of a number divided by 7 is greater than or equal to, so greater than or equal to 10. So we have n divided by 7 is greater than or equal to 10. This is open because we do have a variable in there so that we can't figure out if this is true or false because we don't know what n equals. Moving on to the last section here, it says determine if the given value of the variable is the solution of the inequality, right, yes or no. So for these ones, they're going to tell us what the variable equals, and we're supposed to figure out if that is a solution or not. So number 15, we have 50x plus 12 and 5/10 is less than 55. And it tells us that x equals 5/10. So we can go ahead, substitute in for x, and we are going to use our order of operations. So we're going to multiply first, and then we're going to add 37 and 5/10 is less than 55. That's true. So this is, yes, it is a solution. The last one I'm going to do for you is number 17, which says q over 4 plus 2 4/10 is not equal to 6 5/10. And it tells us that q is 16 4/10. So we're going to plug 16 4/10 in for q. Remember, we're trying to decide if this is true or not. When we add here, we get 6 5/10 is not equal to 6 5/10. So that is not a solution because this actually should be equals. If this was an equal sign coming down through here, then it would be a solution. 16 4/10 would be a solution to this. But because it was not equals, then this is not true. It's not a good solution for our problem here. That's it for the lesson. What I want you to do, I'm sure you've guessed, is the evens. So here you're on page 128, 129, and I want you to do 2 to 18 even. I will be back soon with your homework review for this. Make sure you submit your homework before you watch the homework review, and submit your assignments in Rediker if you're able, or you can email them to me. I will see you guys soon.